What's up, everybody? Welcome back. Today, I want to try writing a DNS client ? I don't really know if a DNS client is what I'm trying to do. I am trying to, when I type in google.com, get a TCP port. How hard could it be, right? And so this is kind of stemming from a little bit of like a major or like a more major project where we're having a bit of a midlife crisis where, Zig has been upgrading for a while. They've got this cool, fancy new IO interface. And I'm like, maybe I don't want to use it, right? I'm trying to find like the line of how much of Zig's standard library do I want to embrace and how much do I not want to embrace. And I might want to make my own IO implementation. I might want to just not use it at all. I might want to use like some subset of it, etc., etc. And so we're kind of like experimenting with bypassing their whole IO interface. And if we do that, and I want to go to open a TCP port to google.com, I can't because it is hidden behind a little bit of work. One part of this thing is there's this host name connect function that they have. And in here, they do this like fancy thing where they try to like dispatch to many places where I think here they do some sort of DNS lookup in here, which goes into the threaded implementation. So if you go to like threaded, they have a net lookup in here who does some sort of DNS stuff all the way down there, right? Lookup DNS search, right? So Zig standard library has this. If I didn't want to use this, the C standard library has this thing getaddrinfo, which I think will synchronously do something similar. I don't really know what. And so if I'm like, I don't want to do either of those things, I maybe have my own event loop that I'm handling, and I want to do some DNS parsing, and I maybe don't link libc, and I don't want to use IO threaded. Like, how the fuck am I supposed to get a fucking IP address? Right? I just want to Google. I want to go Google. Right? And so that's the plan for today, is to try to figure out what that means, right? We're not committing to writing our own DNS client necessarily. We are just trying to see, do we want to? Is like kind of what we're trying to explore. And by we're discovering if we want to by doing it, you know? And so my thought here is, let's write a little simple program. It calls getaddrinfo. Oh, name info is the only correct way. Hold on. Get name info. Is it get name info, not getaddrinfo? It's the inverse of getaddrinfo. It converts a socket address to a corresponding host. Oh, wait, this isn't what I want. Getaddrinfo. I want to go from host name to adder. You tricked me. You tricked me. So yeah, I think we rip getaddrinfo. Then we maybe look at like Musl's implementation of that thing and use that as inspiration, and then like figure out how to do it. Right? I don't know what's going on. We'll say it, and so there's only one way to find out. So can we do, I think in here you could like std_c. Do they have this? They do. If we link libc, we have getaddrinfo. So what is the API to this thing? Man getaddrinfo. You call getaddrinfo with 2 arguments, hints. We are allowed to say whatever. I assume that we're gonna want, like, if we're trying to open like a TCP socket, we're probably asking for sock stream, probably. We are probably also looking for AF-INET, right? If we're saying like, hey, I'd prefer to do an IPv4 connection to this thing. It looks like this is maybe, there might be somewhere where you can maybe do lookups of things that aren't network with this function. I think I've seen something about like this list of service names to service ports and stuff like that. Okay, and then you call getaddrinfo, and I think that this returns a like linked list of addresses in the result. So if we do like, let's just start ripping this shit. Okay, so we have name. Wait, okay, man getaddrinfo. Can we look at what the 2 arguments here are in this example were? I guess we could actually look at what this is supposed to do. So node and service. Service sets the port in each returned address function. If this argument is a service name, see service is 5, it is translated to the corresponding port number. So we probably want to say like TCP or HTTP. I guess HTTP. If service is null, then the port number of the return socket address will be left uninitialized. Oh, perfect. Okay, we'll just do that. So this is probably like www.google.com, right? And then we're probably saying null for the service. Maybe you could specify HTTP, but it would figure that shit out. Hints. So here we have adder info hints. So we have like hints is std c adder info. And what do we say we're going to do in here? Family is std c af inet probably, right? We're like, I want, is it family? I can't remember. So many hints. What hints did they use? They had family, sock type. Sock, stream probably, flags, and protocol. That's what they did in their example, right? So now we're like, okay, rip hints here, and then result here. So what is our result? It's a std c adder info pointer, right? I think. I don't remember. It's a double pointer to a struct adder info, yep. Probably nullable in this world. Okay. And then is this failable? Like, how does this work? What is EAI? I see. This is going to tell us, like, do we have a success in here? Is success one of our options? Oh, sorry, Linux. Right? We're Linux. Oh, I see. This is one of those, like, okay, whatever. Let's see. We'll say return code. And then can we just do, like, hit me with, like, a fucking C int? Like, surely, right? Like, I don't know why they're fucking doing it like this. Can we just fucking hit me with a C int? And if RC is not equal to 0, freak the fuck out. Right? Surely. Surely, right? Like, every C function behaves this way. Zig run main zig link C. Well, flags, he's like, excuse me, I want one of these, so can we just like default initialize that shit, I guess? Same thing. They just have a struct that isn't int, you know, if you think about it. Okay, and then missing field adder length. Oh, fuck. So I guess we have to like initialize these things. But like, you know, whatever. Okay. So that did something. Got this. What is the return code? I don't know. 0. Man, get adder info. I assume that means we're good. Return 0 if it succeeds. Okay, so then we have some sort of like res, and I assume this is a linked list, right? So we can probably do like a while res result. We can kind of say like result is our next. And then we can do like std debug print and just like, what's this thing look like? Fuck it. All right. Look at that, baby. We got some stuff. So I don't know what any of this means, right? So if we are trying to use this to like resolve a host, like, do we just try all of them? Are they in priority order or what? Okay, so he has these fields. Flag specifies the additional arguments described below. Specifying hints is blah, blah, blah. Okay. If the passive flag turns off, blah, blah, blah. Okay, I don't care about hints right now. I want to know what it returns. Res. Am I stupid? Does it not tell me? Okay, a pointer to the socket address is placed in the, oh, here we go. Family sock type protocol fields return the socket creation parameters. Sure. A pointer to the socket address is placed in the AI adder field. Okay, so maybe can we like print out like all of the possible addresses? Like, what is this thing? Sock adder. Is this, and this is one of those like, okay, you have to do like that casting shit, right? So if we have an adder, let's start here. Okay. And then this is probably like switch on a family, right? And it's like, if the family is AF inet, we cast this thing to a sock adder v4, if I remember correctly. So you like take the, can you do this in Zig easily? You're like, I have a stood C sock adder internet, right? We cast it to one of these, I think. So we're like, hey, can I do like A4 maybe is a pointer to this, which is going to be like a pointer cast from A? Is this how you do this? I think this is how you do it. I don't know. This is my recollection of how you interact with this like fucking Linux socket or something. It's like they're like, you know, maybe it's a how do I say this? They're like, you might be trying to specify a Unix socket, an IP6 socket, whatever. And so, nice. Okay. This doesn't look like it did what I wanted, by the way. Because the first field of this is supposed to be the same family field, I thought, but it's not. I thought that's how this shit worked. Because, like, yeah, okay, it's not the way I remember it, right? Because, oh yeah, no, it is, right? Because it's supposed to be family is the first field, and then the data gets cast to this stuff. Oh, I was just looking at the wrong thing, maybe. This is how, yeah, so this is supposed to work. I thought. Maybe it's adder is already a pointer, so it's not a pointer cast to the pointer of A, it's a pointer cast to A. Increases pointer alignment, align cast maybe as well. That looks more reasonable. So all of these guys have the AFINet thing. 0 is 0, nice, and the port is uninitialized, like they said. And so each of these adder fields now is a 4-byte thing, but like shown as a U32, I think is what's happening in here. So I think that we just do like, can we do d.d.d.d? Right, it's something like this, and you say like, can we do U8 takes, like, as U8 takes in a val of U32 and returns a U8, and he just like returns truncated. And then that lets us do as U8. I don't know like which way it is. So, but like, you know, we look at some bits, some more bits. You know, something like this. I don't know if this is backwards. But we'll see. So the question is if we do ns lookup? Nope. How do I like? Is that just, do I just need like inet utils or something? Drill. I seem to remember using ns lookup in the past. Where does this come from? NixOS package search. Dig. You guys think dig? I've heard that one before. Typo, thank you. Look, whoop. It's pretty true. But I think it doesn't, that wasn't the problem. Really? Hello? Yeah, it is just not in there. God damn it. Fuck my life. Dig. Dig. We'll get dig. All right. Am I leaking something that I shouldn't? Ah, it's probably fine. Okay, so I do have it backwards. It's backwards. Not that it really matters, but, you know. So this is by 8, 16, 24. Okay, so if I run my thing, we get a list of this. If I do a dig, we get a list of these things. I don't know if these are the same. They look the same, right? 4, 5, 6, 7, 0, 1, 2, 3. 4, 5, 6, 7, 0, 1, 2, 3. Perfect. Perfect. Okay. So, we have done it. Mission accomplished. However, we do not always link libc. So can we look at what the fuck does Musl do here? Can we just look for like getaddrinfo? What does this guy do? He says, the host part is probably where it gets interesting, right? So he does lookup name, where he's gonna get a list of addresses in this thing, and then for each of the addresses, he like populates the struct properly, and then does some shit. But this is the interesting part in here, right? Lookup name. Here. I know you just gave me the full URL, but I think that it is important to show how I find it when I can find it. You know what I mean? It's like, since we had the thing right there, we might as well just hit the path of like start with the entry point that we know of and then go forwards, you know? Okay, what the fuck does this guy do? So here we have some output buffer, which I think is probably their internal structure here for how many possible addresses they're going to find. This is probably the name, or I don't know what canon is yet. It looks like it's not initialized. So it looks like those are output parameters. Then they have the name, family, and flags. What's that stat 226? Yeah, I don't know. I think that's just saying like, hey, this is a pointer to a thing that you're expecting to be this large, but like, I think that's like strictly for you as a developer, because I think that doesn't do anything, but I'm not sure. Okay, so they set it to 0. They're looking at the name. Oh, I see. This is the canonical name of the thing, probably, right? So you're starting with my www.google.com, and maybe that will turn into something else if they find that the DNS server says that it's something else. I don't know. I don't know how DNS works, man. Don't ask me. Okay. So then they're like, yo, let me try checking if this is just a fucking number, probably is what this means. Yeah, they're like, let me check. Sir, is this just a normal fucking IP address? And if it is, then we're fucking chilling, I assume. Then this is probably the interesting part. So okay, I see. So they start with null to turn to localhost. Then, if it is a number, then they use the number. Then they look at the etc hosts file, I assume, hype, where you can like just put overrides. I think that I shouldn't show my etc host file because I think that there's like some custom stuff in there from an old job I had. So I think that I have to, let me, is there anything in there? Nothing that's actually that scary, but I'm not going to show it anyways, but it's fine if I accidentally leak it. And then they do the DNS search. So this is the interesting part. This is the interesting part. So here they say, let me look at resolve.conf, which is some letters I've heard before from Arch Linux setup, where you like set DNS stuff in here. Do you think that if I type, oh hell yeah. Oh no, man resolve.conf? Oh yeah, here we go. So this is like configuration for people who use libc. We can choose to use this as well. It looks like there's some sort of like specific options, but I assume, well, I guess we'll see how it becomes relevant. So this thing goes into conf. What is in this thing? They've got the address of the name server. I assume ends is like number of name servers, right? So you could have like 5 name servers that you check. So that this is telling us how many of these we used. This is probably how many times you're willing to attempt. This is a timeout, and dots, I don't know what it means, but maybe we'll find out later. Okay, so they parse resolve.conf. So can we look at like Musl getaddrinfo? So he first did name like null goes to localhost. Just raw IP goes to raw IP. Then they did check etc hosts, and then they did DNS lookup, which is resolve.conf, parse resolve.conf, looks like. Count dots, which suppress search when, count dots, suppress search when greater than, oh, I see. Check end dots for if, you know, a.b.c.d.e is greater than number of dots we can handle. Is like probably what this is doing, I assume. Strip final dot for canon, fail with multiple trailing dots, sure. Dot singular. Okay. Then what? Set canonical name, which I don't know if we care about. What the fuck does this mean? I don't know. Then they say, we want to search. What is search here? Search is a buffer. A pointer? Oh, I see. So they have set some point in this buffer to 0, and they're using that as the condition here. So they're saying, dude, what the fuck does this do? Dots equals L. What the fuck is L? L is here. Equals 0. Oh, they're assigning both dots and L to 0. Then they're saying for dots and L equals 0, while name at L exists, increment by 1. If name, so this is counting the dots. We're counting the fucking dots, right? Then if dots is greater than the thing, or it ends in a dot, they set star search to 0, but search, this is setting the first, oh, I see. Maybe. Is this like, hey, yo, if we fucked up, just set the first element to 0. If something's fucked, set the first element to 0, because we want the search to basically not happen. Probably. Right? That's probably what they're doing. But usually they're saying, hey, pointer is the beginning of this array, and we've initialized this thing with the resolve conf, right? Like, what does get resolve conf return here? Like, search is an output thing, right? Oh, this is like a field of resolve conf. Man resolve conf. Man resolve conf. Search. Search list for host name lookup. Okay, so if I cat etc resolve conf, I have search, which says, hey, I have a domain LAN, right? Like my guys end in like, do I have like etc host name? Right? Like I have cave troll linux nixos dot LAN, right? So if I do like ping cave troll linux nixos dot LAN, he's like, that's me. Right? So that's what this search thing means. Okay. So they start with, in this search thing, they're starting with P is equal to LAN, right? I've never seen for and if in one line like that in C before. I hope to never see it again. Perfect. Okay, gotcha. While this thing is set, we do this loop, and then we set P to Z, where Z is who the fuck knows what. Another pointer to some characters. So they're like trimming, right? Trim left. That's what this is doing. Then they start with. Then they Z consumes the whole thing up until the end of characters that aren't spaces. I don't know if is space is white space or just like literally the space character. Is this all just trimming? Dude. This is trimming. Okay, but this is not doing this. This is saying if Z minus P is less than 256. Okay, so here we need the length of the string. So this is like the beginning. This is like head and tail, essentially, of like the search string. Then they're putting it in the canonical name. And then they're calling name from DNS. This was all a lot to basically do nothing. I guess here we're trying to find who owns .lan, maybe? That's probably what's happening here, right? That's probably what's happening here, is that, like, we're trying to find out that my router probably is sitting there with a DNS server for the .lan domain. And so we're looking for the owner of .lan so that we can ask him where this guy lives. It's probably something like that, right? Otherwise, because here they're using canon twice here, but here they're using if there is no search string, then we just fucking rip it normal. I think that's kind of what's happening here. Okay, so it's kind of like lookup.lan search in resolve.conf, and then like otherwise lookup shit direct style, right? It's like kind of like that. Okay, so we really only have to handle this part right now. What's my computer name? Cave Troll Linux Nix OS, because I built my first computer when I was like 10 when Lord of the Rings was coming out. It was tiny, so we named him Gimli. And then I upgraded to a bigger one, and we're like, it's big and strong like Cave Troll, because we use Lord of the Rings style names, and it's just never changed since I was like 10. Okay. So all of this wasn't very interesting. The name from DNS is probably the interesting part. So I've seen this RR thing before. This is like a DNS thing. It looks like they're kind of saying, hey, we have some parameters here. So if we're in INET 6, we're looking for an A, and if we're in INET, we're looking for quadruple A. We got to get our car towed, but like a little better than normal. Presumably we only care about this for now. We don't have to handle IPv6. It looks like they're probably like constructing a DNS request in here. I assume this sends the DNS request. And then here, they're probably getting the response back. Where are they sending it to? Where are they sending it to, right? It's got to be in one of NQQP, cleanse, AP, aliens, A buff, or conf are going to have what do I say here? Where we're going, right? Like in the resolve conf, we had the name server, right? Like, surely he's talking to this guy. Surely. So that was called NS, right? So when we do name from DNS, this resolve conf goes into conf. So is this conf getting passed along? It is. Okay, so name from DNS gets conf, and this guy has the list of name servers. So presumably this guy is going to actually send something? Res msend rc. Okay, so what's he doing? He's like iterating over the name servers, constructing a... I see, like this resolve.conf will tell it if it wants to be like TCP or UDP or IP4, or maybe it's always UDP. Looks like it's always UDP, but this is going to tell us if it's IP4 or IP6. He does a UDP datagram to name server. Okay. What's happening here? Get local address and bind to socket. Handle case where system lacks IPv6 report. Oh, I see. Sure. So here we're literally just like, oopsies. I assume family is coming from the resolve.conf. Yeah, here. Sorry. Here it sets it to IP4, and then if it's IPv6, he overrides it. Sure. It's like, make me a socket, and then I assume we bind that thing with SA, where this is set here, and then how, like, does this stuff not... Like, am I crazy that... Oh, right, when we bind on UDP, we don't need to set the other side. Bind is for, like, our side, and then we send message probably to the other side, send to here. Yeah, so we're sending to name server J, where send to is like, yeah, okay. That's like a C call that sends queries. Yeah, okay. I think I understand. So they are doing all this stuff, finding a server to talk to, ripping a DNS request in a UDP datagram to that guy, and then presumably he's getting some response that he parses. But like we can probably gather that information from the spec, right? I think we had the RFC open here. So presumably we can figure out, well, I guess we have to figure out what request he is sending. That's probably kind of interesting, so that we can kind of correlate what the actual request is with the spec. So where does queries come from? Queries was constructed a level up, it looks like. So query, oh my god. Okay. Res msend rc. Queries was the second parameter. You can tell because there are like 7 words here, but one of those 7 words was queries. So QP. QBuff 0 and QBuff 1. A buff. Dude, what the fuck are we talking about? Does QBuff get set? Yeah, so here they have res make query, and this is where the interesting thing is happening. You may want to parse a generator to parse the DNS response. You're so right. We actually should definitely write one right now. And we wouldn't regret it. We would never regret such a thing. Okay, here we go. So here is where he's constructing the DNS request, probably. And this is so not useful to read. Holy fuck. Right? So, like, this, we gather nothing from this. Okay. So, to me, it seems a little bit like we have a lot of the pieces in here. We have a lot of the pieces. We need to do UDP communication with the name server, which we know, without parsing resolve.conf, is this, right? We also, well, I guess it's more, we are we want to look up the owner of .lan from this address, right? I think that's what's happening. Right? So if we look, like, what happens? What does this mean? I don't really know what this means. It looks like I guess either way, 192.168.1.1 is the owner of .lan because this is my router, which I'm surprised ends up in this configuration. So maybe we just pull this for now. Okay, let's try doing something and just see what happens. So let's say that like around now, let's talk to a name server. And then we don't know what's happening next. We have no fucking idea. But let's try talking to a name server. Fuck, we should leave Musl open. We're gonna want to reference that again. Ah, fuck. You can make UDP connections with current Zig, right? Like, do they have like send message and shit? I don't remember. I know that UDP wasn't super simple last time, but I think it's okay because I don't really want to deal with like bypassing IO and stuff right now. So let's try a DNS test. Pub function main, and let's do a little juicy main. So can we do how do you do this? You do like stood IO net IP address. We're like, can we hit an IP4 address who's at 192.168.1.1? Okay. And then what fucking port are we talking to? There's gotta be like a default port that we missed. There's gotta be. I forget where we were. It was in some like lookup, right? Everyone's saying 53, which, don't get me wrong, I believe you. But, you know. Oh, it was lookup name. Name from DNS search. Have you seen this issue? Probably not. And I won't right now either. Because I'm busy. It's probably relevant, but what if I just reject the idea of looking and then get frustrated later when you gave me the information I need? Res m send rc. Surely it's in here. Surely. Oh, yeah, little 53. Nice. No, it's random. Oh, okay, perfect. Okay, 53. So we'll call this NS adder. Fuck it. And then can we do a little NS adder connect? And we're like, hit me with some IO. And I guess we want mode is dgram. And protocol is UDP. And let's hope that we can talk to him. Server. NS, we'll call it. Does this run? Who fucking knows? Easy. It ran. That's too many letters in a variable involved in name resolving. You're right. Sorry, we should use LPZ, QP, QL, L. Okay. So, do they have, like, send to? No. Like, so, how do I say this? Zig's, like, IO readers and writers are very, like, stream-oriented, right? Like, does Can I do like a datagram send right now, or do I just have to like roll my own like send to right now with like, do I have to do one of these like with a stood, POSIX system send to that like does the socket stuff directly? You're saying roll your own to save some sanity. You're gonna dislike the way Zig does it. Okay, I believe you. So because so far like the vibe is that if I want to do this, I do it like this. You know what I mean? Okay, so we're like, I want to send a buff. We have the len automatically, and then everything else we just kind of pass through. This thing is going to return. How the fuck does send to work? Message length flags, that's error, and it returns an S size T, which is probably like return code or the number of bytes written. Otherwise, anyway, yeah. Okay. So this is going to return usize, I guess. Okay. FD buff pointer buff len flags adder. This is system dot. How does send to work? Says the guy who wrote a Wayland compositor. Yeah, exactly. Yeah. You have to understand that the knowledge is always really limited. So we get one of these. This is probably a little while truesies because enter, and then we do like a little switch on stood POSIX erno. This is the new way, guys. This is the new way. Okay, enter. We continue, and anything else instead of doing anything properly, return error. Uh-oh. Yeah, says the guy who wrote a network stack for his kernel. I did write a TCP implementation. I forgot about that. Okay. Wait. What is des adder des len? Right here, we can probably get a little fancier, but it's okay. I see what's happening here. So we're saying, hey, I have a file descriptor, my UDP socket. I have a buffer that I want to send. I have some flags and an address. Perfect. Okay. This might be a stupid thought. Does connect even like exist here? What does this do? Right? Because it's not a stateful protocol. So like, what does this even do? Am I stupid? Net, connect, IP. Like, if we see UDP, what the fuck does he do? POSIX connect. It gives you everything from the IP port to remote port pair. I see. So, like, this guy does open, which calls socket. Then this guy calls, I presume, just connect. Yeah, so I guess the answer here is that, like, the connect syscall is allowed to be UDP. I see. So, like, the whole point of this is that I can call write without send to. Which is kind of nice. Okay. I see. So, like, maybe I want to do this instead. How does bind work? Do I have this? Bind options? What does this let me do? Yeah, I guess this is more what I'm trying to do. If I'm trying to match what Musl did, we should bind. And then we can call our send to on this directly. I see. Okay, that makes sense. Makes sense. Okay. So now we have to like construct a UDP packet. Or construct a DNS packet, which I don't know what they look like yet. You know? But we'll figure that out. So There's some shit about RR. Where's like header? Let's start with like header. You know? Is there a header in here? Header. Messages. Format. Here we go. Oh, I can't regex search in this thing. Right. Oh my god. Okay. All communications inside of the domain protocol are carried in a single format called a message. Top level format. This is a little loud, huh? I'll turn that down a little bit. Top level format of message is divided into 5 sections, some of which are empty in certain cases, shown below. Okay. Header section is always present. Okay. Header includes fields to specify which of the remaining sections are present. Okay. And whether or not the message is a query response. So I presume we are doing some form of query. Names of the sections after the header are derived from their use in the standard queries. The question section contains fields that describe a question to the names. Okay. Not my question. The question of our client. He is asking the question of who the fuck is google.com? So these guys are specified with Q's up front, right? So they're like, what type of question am I asking? What class of question am I asking? And what is the name of my question? Last 3 sections have the same format. Okay. 16-bit identifier assigned by the program that generates the kind of query is copied to the corresponding reply. So this is like for us to correlate our request and response. QR is not for QR code. 1-bit field. Okay, so this is what are we looking at here? This is 8. This is 16 bits across. And then I never fucking know when I'm looking at this, like which order the bits live in. So can we look at Musl and like what do they do? When we saw like it was res mic query or something, right? So this is 0, 1, 2. So if they're trying to set op times 8, that makes it look like the lowest bits are on the right, right? Because they have an opcode in here, and they're multiplying it by 8, which is equivalent to a shift by 3, which does 1, 2, 3 shift to the left. That sounds right. That sounds right. Okay, cool. Cool. So, high bits on the left. High bits on the left. So let's do a little write query packet. Buff. IO writer fixed on buff var w is this, and so here what are we doing? We have like an ID, which is a use16, right? Yep. So write int ID. Okay, is this little or big? Network. Surely it's network byte order, right? It's always network byte order. Byte order. Byte order. What? Is it in the header? No fucking way. What am I looking like? Oh, index byte order 8. What is this? What does this mean? Where am I? Ah! Don't use this site. Yeah, you're right. We should download RFC, which is maybe not what you're looking for, but I mean, it's the same shit. Okay. I mean, this is the same RFC. Data transmission order conventions. Here we go. 2.3.2. The order transmission of those octets is a normal order in which they are read in English. For example, in the following diagram, the octets are transmitted in the order they are numbered. 1, 2, 3, 4, 5, 6. When an octet represents a numeric quantity, the leftmost bit is the higher. Oh, nice. We could have figured this out. When a multi-octet field represents a numeric quantity, the leftmost bit of the whole field is the most significant bit. So that's big. Big. Big, 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 big. Write int. So we're writing a u16 to the ID big style. Okay. Okay. What was it? Chapter 4? Header. Here we go. So then we are looking for this guy, right? This is B2. And then this is 1, 2, 3, 4, 5, 6, 7, 8. Yep. Okay. Okay. So var B2 is QR shift left by 7. 7? Yeah. Plus opcode or opcode shift left by 3. Or AA shift left by 2. Or TC shift left by 1. Or RD. That's what we're looking at. Okay. B3 is RA shift left by 7, and then what is a Z shift left by 4, probably, and then R code, probably. I think it's like this. Something like this. Okay, and then I guess we have like QR is query response. So QR is query 0. Query is 0. So I guess this is kind of turning into a write DNS header. Maybe this takes in the writer directly here. Maybe. We'll fucking see. We got ID, QR. What's next in this motherfucker? Opcode, U4. Right? Yeah. And then AA, TC, RD. All these are 1 bit. I guess maybe we have like DNS header params is like a nicer way to represent this. Is AATC RD. Because then all these things have to be named when they're used, you know? Z was a U3, I think? Yeah. And then what was the other thing? R code. Okay. So then I guess maybe this is like write to a writer. You know, kind of like this. And then we probably want like an as U8 in here. Which actually did we have that already? I feel like we did, but whatever. Which is just like return intcast here. This will just help with the upcasting to make it like, because I think that these shifts don't really work this way, because you're like shifting a U4 by 3 and it goes like you can't fucking do that. So we need to like as U8 all of this shit, I think. I think it's like some dumb shit like that. You know what I mean? You know, so I think it's like this, which is funny. All of this. This is good. Good coding. I guess we can just order this now. Uh-huh. Sure. This works. And then we can just do like try self write byte or W write byte. Okay. And then we can just kind of slam all of this inside. Boom, boom, boom. And then what is like the formatting here that doesn't suck balls here? Probably like this, right? Maybe pipe on the left. That feels kind of nice. That feels okay. That's passable. And then this shit again. Okay. Okay, there we go. Jesus Christ. Okay. Forgot this one and this one. Okay. Now what? Now what? Then a bunch of U16s. Which you don't know what they mean yet, but we'll get there. QD count. And count. Nis count. And R count. Okay, and then we just rip those. Maybe we copy, paste, try write int, U16, self dot, and we forgot to go big style. There we go. We got there. We fucking got there. So now the question is what? So this header, if we are trying to send a query, like we're kind of starting with this, right? We're starting with, I just fucking want an IP address from a thing. So now we can figure out, like, what does that mean? So we think QR should be 0, right? Because 0 means it's query. Opcode. Am I a standard query? Inverse query? Server status? Surely I'm a standard query, right? Surely. AA. This bit is valid is responses, so, this is not an answer. We are a request, so I assume we just write 0 here. TC specifies that the message was truncated due to the length greater than the permitted. Surely that's a false. Surely, but we would probably have to check MTU, which I don't know how to do, so kind of fuck it. Recursion desired. This bit may be set in a query and is copied into the response. If RD is set, it directs the name server to preserve the query recursively. That seems good. I would like it to do that. Fucking go fucking ham buck wild. I don't give a shit. I just want the fucking IP address. Do what you want. Do what you fucking want. Recursion available. This B, okay. This be set or cleared, matey. In a response, what? It's so funny. And to know whether or not recursive query support is available on the name server. So they'll tell us. They'll let us know. So for now, we don't give a shit. Reserve for future use. Make it fucking 0, baby. 0 is 0 if you think about it. If it's 0, it's 0. Response code. This is that. So surely we just 0 this out for now, right? Surely. And this is specifying the number of entries in the question section, number of entries in the answer, number of name server resource records that they're in the authority records. So presumably, we just put one question, right? Surely. We have one question. It's who the fuck is this guy? Who the fuck is this guy? Surely. The question in most queries, i.e. the parameters that define what is this. Maybe we can see what Musl's doing here. Not that this was very, useful information to us when we looked before. I don't like when everybody in chat says surely with me. It makes me think I'm saying something fucking stupid. But, okay, so we think, oh my god. We think that the question count is byte 1, 2, 3, 4, 0, 1, 2, 3, 4. So what do they set 4 to? Oh, good, they don't set it. That's perfect. I wouldn't want them to set the number of questions. Because that would be fucking crazy. Right, that would be crazy. Maybe we're saying how many answers we want? Right, 0, 1, 2, 3, 4, 5. I guess it's 4 and 5. So because this is a U16, they're setting the low bits of the QD count to 1. So they're sending one question. They're sending one question. Perfect. Wait, no, I was right. I was like, surely. Musl is the Canadian pronunciation, I assume. What do you guys say? Do you guys say muscle? Musl? That might be a Canadianism. Are there any, like, why do I say it like that? Are there other words that are spelt kind of similar that have, like, a Canadian U in there? There might be. RFC says usually one. Yeah, well, I can't read. Okay. Okay. So, 1, and then the rest, I think, are 0. So, okay, and then we need an ID in here. Cafe, food. Oh, it's only, sorry, it's only 16 bits. Food. Okay. So we have our header. Now what? Question section format. So presumably this just rips straight after the header, right? Because I think we saw a picture. Header, question, answer, authority, additional. So we just ignore all of that shit. We just go hard in on question. And here, I assume that so the name here is what? The domain name is represented as a sequence of labels, where each label consists of a length octet followed by the number of octets. Okay. The domain name terminates with the 0 length octet for the null. The domain name terminates with the 0 length octet for the null label of the root. I guess they're saying like 3 www, 5 google, 6 google, 3 com, 0. Is that what they're saying here? That like each label is like one subsection of the entire name that you're querying? That's how I'm reading this. What does Musl do? Greyhatter says correct, and I think he's written a DNS server, so sounds pretty good. They are splitting on these. I have no idea what the fuck this is doing. But that's what I'm reading here, so I'm just going to do that because Greyhatter said I'm right, and I'm usually not willing to accept his help. But in this case, I don't want to I don't want to read this. Right? I'll say it. I don't want to fucking do that. So, fuck it. Okay. So let's say that we write that header. And then we want to do like write question. Write question. Name. Right? Surely this is what we're doing. And so we're saying, we want to do like a little std split scalar on the name. We're looking for some dots. You know, we get some section. And we're like, if section len is greater than 255, freak the fuck out. Doesn't fit. Easy. Oh, you guys are saying I've got it backwards? You're saying I should be doing com google www? It ends with the root. Yeah, I mean, I don't see them doing any like fancy backwards shit here. So I'm gonna go forwards, and then if I'm wrong, I'm wrong. You know, I weigh w w. Can we start doing I y w y w? If you wrong, you wrong. Here we like write byte of an int cast section len. I guess you could also do like len 8 is, you know, a little std math cast, so we can use some little nice zigisms. If you're wrong, spelt with R's is very funny. I actually like that better. If you're wrong. That's so funny. It's so fucking stupid. Okay. Write all of the section, right? And then we just rip all of those, and then we write a 0. That seems good. So this is name. Maybe this should be a function if we're fucking putting a comment of a function name and then putting scopes around it. But, you know, it is what it is. What's next? QType is a 2-octet code which specifies the type of the query. What are our valid types? Don't know yet. Then there's class, which is 2-octet. Write int u16 qtype big. Was it qtype then qclass? Yeah. And then can we just figure out what these could be? QType values. A, host address. Surely we just want A's, right? We saw quadruple A's for IP6 somewhere and A for IP4. So I'm kind of down to just, oh wait. Q types are a superset of types. Oh, in addition, we have these guys. Let's just throw some A's in there. And then class is internet. You know? Are these numbered? Does A, are the value type, value and meaning. A is 1, I think is what they're saying, right? Can we do maybe a little enum qtype? How do you do this in this language? Const qtype is an enum, and we're just gonna say A equals 1. And then we're just like qtype.a int from enum, like this. Maybe, I don't know if maybe I'd prefer if we didn't use like enum values, but did like a serialization function, but like whatever. And then const q class and enum. And what are options? Like inet. I think that's what we saw in there. Oh, just in. Okay. Sure. Fuck it. DNS basic seems surprisingly guessable. Where do the nightmares start, chat? Yeah. I'm sure it just seems guessable because we're guessing with no check, right? We're just being like, I don't know, fuck it, we ball. And in a second, someone is gonna get really mad. Right? That's my assumption. All right. So now we're like, right question. Right? Yeah, fuck it. It's funny, I don't know why. Header.right feels wrong to me. It feels like it should be right header here that takes in the header as a parameter, but I don't really know why I think that. That's just like a complete like style thing. But it's a style thing that I feel in my fucking bones. So what you gonna do, you know? Okay. So can we have some buff that's like, surely our request is not this big, because I think like MTU is usually like 1600-ish. It's like around there. So this is like way too big. Then we can do W is a stood IO writer fixed around this buffer. And then we can do a write DNS query of, you know, into W with www.google.com. And then we send that shit. Right? RFC says 512 is the largest query size. I believe you. Const DNS query max is 512. And then can we, fine, 512. Size limits. So RFC, what is this? 1035 section 2.3.4. Okay. All right. So we are now sending, I guess this thing needs to tell us the length, right? No, because the writer has it. So we're like, W buffered? Okay. RIP. Flags? What was it? I forget. I forget what it was. Res make query and res msend whatever the fuck. He said, give me message no signal. What the fuck is he doing? We got flags, no signal. Requests not to send the SIG pipe signal if an attempt to send this is made on a stream-oriented socket that is no longer connected. Oh, sure. Dude, that's crazy that that's a default. Wait, oh yeah, of course I want that. And then what is he returning here? He's saying he's like getting the address of who this went to, right? No, this is who we're sending to. We're sending to. I'm a fucking idiot. I'm a fucking dumb, fucking stupid idiot. Okay. I think that there's like a address to POSIX in here that does that part for us. So we're like, send to this guy. And can we put this in send to storage or something? Which is a stud IO threaded POSIX storage, POSIX address. Boom. We're like, here you go, sir. Perfect. NS LAN here, and then this goes in here, so we have like sent to storage NS LAN, I believe is how this works. I think that they want this as any. Yeah. Oh, it doesn't matter, I guess. They're all the same. I'm not sure. And then system message no signal. Okay. Then we just wait for a response. So we need receive from, which I assume also doesn't exist anymore. Yeah. Function receive from. What does this thing do? System receive from. We'll copy paste, oopsies, the Linux version of this API back here. Boom, boom, boom. This guy's going to return probably however much we received, probably. So this is going to be like RC is we pass all the shit along, but buff is going to come in as an actual slice for us because we like that shit. Flags, adder, ALAN. Okay. This is while true, probably, right? Because we might get entered. We do like switch on the stud POSIX no RC. If we see success, we're chilling. If we see a enter, we go again, and otherwise we return error received from, and we figure out, you know, error mapping later. And then we're like, let's receive some fucking packets, you know? I guess NS is wrong, right? This is like dgram, like I don't know, socket. We'll just call it socket. So we're like, hit me with this socket. I want to receive into receive buff. Okay, cool. What's next? We got some flags. What flags do we want? I think I'm down to just do none of them. Surely. Surely that's fine. And then I don't give a fuck who it came from. I don't give a fuck. Okay. So received is receive buff from 0 to receive len. And now we can run it for the first time, and we're gonna fucking hate ourselves. REC received. I before E, except after C, and then a bunch of other fucking times. But I think that looks right. Okay, right header. I think it should go W then header. All the airplane references are killing me. I've actually never seen that movie, so I don't. If I'm making references, it's like purely by mistake. I don't think len should be 0. Well, we'll see, but it's a pointer to an output len, right? So they're both nullable. I think it's fine. I think they're both fine. I think we forgot the any here. And then send to. Can we just do like a quick little assert here that like sent is equal to the buffer to len here? Because if it's not, we're fucked. Receive from handle, please. Address unavailable. What do you mean? Oh, because I'm trying to talk to them, not me. Oops, this is my adder. Oopsies. Let's fucking do. Just fucking rip anything. I don't give a fuck. Go crazy. Go fucking crazy. Then this is just a different thing. Wait, I need both. I need both. We have NS adder, socket adder, 0000. I don't give a fuck about port. This is socket adder bind here. Is that better? Missing field port, so I need it. Can I say like 0 for like I don't give a fuck? Like fucking pick one for me, OS, please? Please, God? Holy shit, they sent us something back. That's shocking. You want send, not send to? Holy shit, that's a packet. And look at this. Look at this. I think those are the fucking numbers, right? Dig? Dig? Hello? Who was digging before? Dig. Right? 142251, 142251, 150, 119. Those are the fucking numbers, baby. Holy fucking shit. Wait, I don't know why I want send, not send to. What's the difference? Man. Send. Yeah, you are right that I do just kind of want to fucking... No, because I'm trying to send it to a specific guy, right? So either I connect and run send, which we're not in connected state, because I bound instead, right? I was like, because we don't know if we're going to talk to multiple name servers. Was kind of my thought here. Well, really my thought was I'm copying Musl, but then it's like we might want to send, if you don't want to bind to the remote, you send to and include the remote. That's what I'm doing. That's what I'm doing. Because we might have multiple servers. Send is after you connect. Yeah, we didn't connect. I see. I'm actually, so maybe I'm a dumbass. Is connect for UDP specifically like a Linux concept? Because like in my brain, UDP sockets don't connect. You just kind of like have a port over here, and then you like rip some shit over to the net, and then the net rips some shit back to you. But like you're not like connected. Bind is only for local address. Yeah. So you're saying like connect is a row in a kernel table. Yeah, okay. So it is not like a network concept, right? It's like a my computer's inside his brain concept. The kernel just remembers. Yeah, gotcha. Gotcha. Bind is the host address. No, I understand that. I'm saying like the concept of connect is just confusing to me. I'm like surprised it exists at all. But it's just like a little nicety, I guess. Little nicety. Okay. So now we just have to parse the response. Which, like, how hard could that be? Parse the DNS response. Okay. I don't know what this is gonna do yet, so we'll just return void. We probably have like, it's weird. I like that, like, writing the header feels like it should be one thing, like, be external, but reading the header sheet feels like it should be internal. I don't know why. Very asymmetric, but what you gonna do? And it feels like this shouldn't be called DNS header params anymore. This should be called just, like, DNS header. And we just do this in the reverse order, right? Or same order, even. So this is ID, our read int. Okay, this is B2 is our read byte, and then we say QR is a truncate of B2 shifted right by 7. We got opcode is a U4, which is a truncate of B2 shifted left by 3. AA is a U1, shifted left by right by 1, and then 2, 1, 0. Okay, so that's that. Okay, so then we have const B3 is our read byte. Probably try. You always gotta try. And then so we kind of maybe group it like this. Then we say const RA, which is a U1, is a truncate of B3, so 57. We got Z, which we really don't care about, but whatever. Okay. And then we got QD count is our read int, U16 big. And then it's AN, NS, and R. R. Okay, we did it. Can we just do a little copy paste here now that we've kind of done all the actual work? Copy paste. We do a little this, we do a little this, we do a little macro where we do put a dot, find the colon, place an equals, find the dot, yoink to the end of the word, go to the end, paste, comma. Oh, I fucked it up because I pressed. Hold on. We're gonna edit the macro. Oh, we're gonna do it again. Fine. I accidentally pressed a button I didn't mean to. Put a dot, find the colon, replace with an equals, delete to the end of the line, go back, yoink end, space, paste, comma, go. Go. Okay. Cool. I feel like the syntax highlighting is fucked for some fucking reason. Some bracket is not matched. Ah. Wait, why did I lose opcode? All right, does that work? Unused function parameter? Are you joking? It's used everywhere. Oh, parse. My bad. Fine. Okay, let's read the header. Where is my syntax hiding? Const header is DNS header read from R. Var R is a stud IO reader fixed of received. Beautiful. And then we can print the header. He's mad. No field read in. Are you fucking joking me? Taken? Oh my god. All right, try again. QD count. I forgot to try here. Okay, nice, nice. So we got some shit back. Looks like the recursive shit was supported. They have 8 answers for our one question, and we're fucking big chilling like you've never seen in your fucking life. Okay, so if we're trying to get to the answer section, message format 4.1. So the question we are free to skip over, probably, right? I guess we have to like discard the question. I wish that we could just like remember the length, which we probably can, but this is probably safer. Discard questions are stood IO reader pointer. And we are saying how many of them are there? What is it? QD count? Okay. And we're saying for QD count, we parse discard Q class or Q name, I think, right? And this is like R take, while true, we do an R take byte, right? And then we do like discard all len. Right? Just like this. I think. So then here we're like discard Q name, then skip 32 bits, right? Right, 2 U16s for the other two things. Okay, easy. So now we should be able to be like, discard questions. Like this. And then can we print the rest here? Can I like take remaining or something? Buffered maybe, like this. We do need to pass R as a pointer, so true. We do need to try. And then 165, we probably need to try there as well. Perfect. End of stream. Okay, so we fucked up. We done fucked it. I mean, that doesn't look like what we sent. I'll tell you that much. Okay, so we read 1 U16. U16, 2 bytes. Then 4 U16s. 1, 2, 3, 4. Is there some like alignment bullshit that's going on now? I guess it'd be interesting to hex dump the response and see if we see our question in there. Right? That's what maybe the easiest thing to do here. So can we do stud IO file open, maybe dir current working directory open file, create file. I'm still getting used to the new IO shit. We're like, make me a file, and we'll call it, test bin. And I don't give a fuck about flags. Let's try. We have const f, and can we like f dot write all? Is that like write streaming all? That sounds right. Sounds like what I want. If you have Wireshark, it's a great way to see it. Yeah, but opening Wireshark on here is a disaster. That's a no-go. That is a no-go. Because like you just leak shit. You know what I mean? Can we do a little hex dump -c? So I do see my request in there at around where I would expect to. Right? So I see a 3 followed by www. Did I forget to break my loop on len equals 0? Is that the only problem here? Yeah. If len is equal to 0, break. There we go. Okay. So now we are seeing the answer section. We might see our 192.168 XY IP address. No, but like you can just like accidentally leak like important shit. You know what I mean? So this is just easier. It's fine. We have your credentials already from the Twitch chat streams. Yeah, true. Okay, so we have this, and now we want to parse our answers. So I guess it's like 4 0 to header answer count. We do something, right? Surely, right? Like probably something like this. I don't fucking know. Right? Surely. What does an answer look like? Message. Hello. What chapter is this? Format. 4. Okay. Question format section. Resource record format. The answer, authority, and additional sections all share the same format. Oh, perfect. A variable number of resource records, where the number of records is specified in the corresponding count field in the header. Each resource has the following format. So name and rdata are variable. And then we have these things, which are just U16s. So what is the format of rdata and name? Both of these are probably the same, right? Like a domain name. Like is name the same as the question name format? Probably, right? Where does it say? Hello? The domain name is contained in a part of the message. Wait, no. A point. Message compression. Wait, we're not. This is a different section. The domain system utilizes a compression scheme which eliminates the repetition of domain names in a message. Oh, Jesus Christ. Okay, so the names might be this like compressed bullshit, maybe. In this scheme, an entire domain name or a list of labels at the end of a domain name is replaced with a pointer to a prior occurrence of the same name. The pointer takes the form of a 2-octet sequence. It's going to point to the name in the question section. Oh, probably. The first 2 bits are 1s. This allows a pointer to be distinguished from a label, since the label must begin with 2 0 bits, blah, blah, blah. Okay. So the compression scheme allows a domain name in a message to be represented as either, is this a domain name? Yeah. As either a sequence of labels ending in a 0 octet, a pointer, a sequence of labels ending with a pointer. Okay. So this kind of means that like the reader API is kind of fucked, right? Like using a reader to read this thing means that it doesn't really make sense to go backwards, like from. I guess you can, right? Because we know that the reader is a fixed reader, so it's fine. We'll just fucking hack it for now. Okay. So it's DNS RR is what this thing actually is, right? And it has the structure of this. Now, name is interesting because name cannot be represented as a const U8 without allocating, because you might have like, piece of name plus like pointer. You know what I mean? So you can't really just like the name might not exist in the original bytes. Name buffer 256, yeah. Isn't the 256 limited to a section of a name, not the length, not the name as a whole? Right? Because you can have multiple length fields in a big name that, like, I didn't see anything stopping you from having 255, 255, 255. The full thing must fit. Oh, okay. If you say so, I believe you. I believe you. I believe you. So type is U16. Class is U16. TTL is U16. RD length is U16. And then what's in R data? Variable length string of octets that describes the resource. Format of this information varies according to the type and class of resource record. For example, if the type is A and the class is... But also, like... Oh, you do actually need to parse this, right? Fuck. The R data field is a 4 octet. Okay, sure. So we will for now... Wait. Oh, we just don't have to care. We actually just don't care. Because we can just go, we can kind of give this to him as is, and then he'll figure it out later. Read. Our V table is 10. Like, can we do a little fixed? Reader is stood IO reader fixed on an empty buffer. Then can we get a V table out of this? Yeah. Like, I just want to make sure that this is a fixed reader, because we're gonna abuse that. We are going to abuse that shit. Okay, so name. So we're gonna do a take byte, right? And if name len is this, but if name len shifted right by 6 is equal to this, then this is a pointer. Right? So this is an offset to what? Is the offset relative to the beginning or the end of the number? From the start of the message. Oh, nice. Okay. So I guess we want, like, maybe this? I don't know yet. I don't know. We'll just put a U size for now. Fuck it. Var name is a stood array list U8. Init buffer of something. I guess like this. I guess. Sure. So then we have some sort of like while true, we're looking for like if name len is 0, we break out of the loop. We're done. If this is like this, we have the like offset is name len and 0x. There's an f on the bottom, and then 2 bits, so 3, 0x3f. That sounds right. And so then we say, I guess like, I guess it's kind of like, can you point to another pointer? I wonder if it makes sense to do this. Var namelen is this, while namelen shift left right by 6 is 0b11, then you can kind of like follow it naturally. You know what I mean? No, pointing to other pointer is invalid. Yeah, and also I don't really think it follows naturally. So we just won't do that. So if namelen is 0, we break. If it's a pointer, then we say actual namelen is the our buffer at offset, and then we say name append slice of the buffer from offset plus 1 to offset plus 1 plus actual namelen or something like this, and then we like fix me bounds checking LOL, right? But like it feels like something. Is this Zig and not Rust? Yep, it is. Sure. And then if otherwise, I guess it's like continue here. Then we read the next nameling. Okay. Then we have the other case, which is like normal. So we're like name append slice r take nameline. Yeah. Something like this. Bounded. Try here. Try here. Try here. Bounded here. That feels like a little bit right. Why shift by 6? Because it looks like this. If there are 2 1s up here, then it's a pointer. So you're like, we're checking for these high 2 bits here. Oh, but you are kind of right that it is a 2 octet sequence. I thought it was. I misread this. Fuck. So you actually have to do another byte. So this is like the offset high. Offset low is take byte, and then we have to do make this a U16. So this is like offset shift left by 16 or 8, I mean, and then or in the low byte, the low. It's a good thing you asked because I would have been wrong. Right? Because I missed that this is 16 bits. If it's a pointer, right? So that means if it's not a pointer, though, I assume that means that if it's not a pointer, then it's a label, and labels are like that 0, like that like 1 byte string length thing. I think 3F has got to be wrong in there. Why? 4, 4, 5, 6. I think that's right. It's because it's not what I'm doing? Okay. Okay. Well, what you gonna do? That feels kind of right to me. We'll see what happens. Okay, so then after this fucking bullshit, we read type class TTL. Jesus Christ. R take int U16 big. And it is, I guess we have them here. All of these guys. So can we do a little macro magic? Const this equals try R take int U16 big delete go go go. Nice. And then const R data is try R take RD length. Okay. And then we should be good to just fucking rip it, right? So we have name buff is name buff. We copy paste those whole 256 bytes. Hopefully the compiler is smart enough to like not freak out, but like you never know. Okay, we got this thing, we got the tip is tip, we got the class is class, we got the TTL is TTL, we got the RD length is RD length, and we got the R data is R data. And then we just kind of hope to God that this works. We are missing when he's 6, he's mad because it's like he's like, bro, I need to return a thing. We're like, you're so true. We are just ripping an end of stream over and over again, so someone's not happy. Someone's not happy. So can we maybe hit a little try here so that it'll actually like freak the fuck out and give us a backtrace? Perfect. So we are hitting this on take RD length. So can we std debug print? I would like to print the name that we got just to see, because that seems like the most likely place for us to be doing something fucking stupid. So I would like to see, like, is that right? www? Wait, huge? I'm confused about in our answer field, where does the answer start? I don't know. I don't know. Can we start with like off rip? Can we look at maybe our is it seek? I think it's seek. So we're at 32. So that's here. Oh, so each of these is an answer, probably? Each of these lines is an answer? So this is... Yeah, okay. Hold on. So this is the name. First byte. C0 is C11. What am I fucking doing? What am I fucking doing? C0 shifter right by 6. 3. Yeah, okay. So this is like I'm a pointer. And my pointer is at offset here. Oh, maybe the problem is that I am parsing the pointer not as like a full label. I'm parsing the pointer as like a pointer to a section of the thing, but it should be a pointing to like the whole fucking shebang. So this is like, again, oh god. Yeah, okay. I see. Out is, I don't know. We'll figure this out later. But this is gonna be basically part of this. You just kind of rip this middle section out of this. There we go, right? And then this is down here. Parse label, and I guess we make a new, like, offs are is stood IO reader fixed around, our buffer from offset on. Like, something like this, right? Something like this. Something like that. I have test cases, you can borrow them if you like. You want the answer? No, I don't want the answer. Cheating. No cheating allowed. I think that works. Try. Okay. Fuck. Hold on, hold on. Perfect. Perfect. No cheating allowed unless he says so. Yeah, there we go. That is the way it works. Okay, so it looks like the name parsed successfully. So that seems good. What is my RD length? Really fucking big fucking massive fucking dong. Holy fuck me. No wonder he's like, excuse me, sir, I can't fucking read that. Did I get the order wrong? Type class TTL RD length. Type class TTL RD length. Is that big, Endian? I mean, it says big here. Are you giving me a hint that it's not? No, but like, no, I mean, I don't see. Okay, can we look at the rest? That big number is C600. Why would this one not be big? There's no way, right? Can we look? Can we print them all? Can we print them all? Can we do a little macro copy, paste, delete, word, do, stood, debug, print, this thing, call by number, and we go back, yoinkies, pasties. Okay. Type 256. Class 256. It is the fabled middle Indian. Love your stream, man. Thanks, man. I think I actually might have seen something about the host being able to tell us if he wants to speak big or little Indian. I don't remember if that was in this spec or another one I was reading. It's all big? Okay, but then, like, am I off by one or something? Does a pointer not follow? Oh, pointer's the last thing. If when we go back to wherever the fuck it was talking about the pointer, he says, hey, you can be a sequence of labels ending in a 0 octet, a pointer, or a sequence of labels ending with a pointer. So the zero at the end does not happen. The pointer marks the end of the sequence. You can't have like pointer plus extra. So I'm probably off by one everywhere. Yeah, baby, let's fucking go. Okay. Now I'm probably off somewhere else as well, right? Because when we hex dump this thing, we're seeing that all of these records are like identical, right? So after we parse the first one, all of the ones that we parse after that should be the exact same. You know what I mean? If I recall correctly, I think I made this exact same mistake and thought that was my bug too. Are you saying that that's not the bug? Fuck. I mean, that made it make more sense. So, I mean, okay, how many bytes should we parse in this answer, right? That's the next question we should look at. So, this is 16, right? So each answer should parse out 16. So I would love to see const start is rseek. Then can we defer a print of found, like RR was this many bytes, right? Ooh, we're still fucking shit up. We're still fucking shit up. We're still fucking shit up. Okay. I have 2 more bugs? Hell yeah. Wait. Sick. Okay. Interesting. You weren't wrong when you said this is insane. Okay, so we're expecting 16 bytes, right? We know that we have 1, 2, 3, 4, 5, 6 consumed by this. 7, 8. So we have 8 more bytes to pull. I guess we should assume that the IP addresses are these last 4 bytes, right? Looking at this, we see these guys like this, right? 1, 2, right? We see like monotonically incrementing IPs. And then we also see the length here is 4, right? So presumably, if we're getting something that's not 4, it means that we didn't parse enough of the name, right? So working backwards, this is length. And so we have, how many fields we should have? 1, 2, 3 before the length, right? So this is length. We have 1, 2, 3 before length. And then this is the whole fucking name here. Unless I'm off by 1. 1, 2. No, I think that makes sense. That makes sense working backwards, right? So this is the pointer. 1, 2, 3, 4, 5. Hold on. Did I forget something? 1, 2, 3, 4. Did I forget something in the 1, 2, 3, 4? No, okay. So it's gotta be that the fucking... It's gotta be that this is part of the name somehow. Right? Stare at that table format a little longer. Ha! Thank you. Dude, come on. Like, come on. Come on. Okay. Who's supposed to... How are you supposed to see that shit? How are you supposed to see that shit? If only I told you it was 30 bits. Okay, shut up. Shut up. I see it. They told me I'm just a fucking stupid idiot, fucking loser, dumbass, okay? But like, fine. Let me have it. Bigger box means bigger bits. Yeah, of course. Okay, but I mean, so it looks like we have the answers in here, right? TTL of 32 bits is huge. Yeah, you can really ask it to wait. Okay. So now all of these things are telling us that we have like a google.com associated with this IP address. And I assume that like it's just based off type and class, right? So like we have like type here. So we have an answer. Class is 1 as well. So are we like done? How do we know it's an answer? It's like in the header, right? This is authoritative answer probably, right? Do we print the header here at all? This might be a stupid question, but all of these answers, do we assume that everything in the answer list is like an IP address? Or sorry, not an IP address, because it depends on the type of class. But all of these are like ways to refer to the guy, right? So I think that all we have to do to resolve is just rip the response, look at anything that's like a type and class that matches that we can ask for. You're asking for a class A. Yeah, so we did ask for A's. True. We asked for this specific IPv4 answer thing. So I think that we can just list all the responses. And then those are all of our like candidate IPs. And then we're done. Right? Like, I think we have all the info. So the next piece here is if I wanted to like hook this up to like an external IO system, like the first step in here is like have queries, like have a DNS query structure that does some sort of async request and gives us the answer. And then I see why now Zig's IO implementation then does like a spam of like just fucking connect to all of them and see which one hits first. I don't really know. Like, I assume that you can just go in order as well. I guess like there's a reason that you would want to parallelize the next part of this thing, which is like try to connect all these things, because like some of them might be down, right? So I guess it kind of makes sense to have some sort of system that can like make a connection to all of them and just give up on all of the ones, or like give up on the ones that lost the race. I kind of see why Zig did it that way. That seems kind of crazy to me. Like wrong in terms of like intentionally sending out a bunch of traffic on the network that I don't want. It feels aggressive. Yeah. That's how I feel too. It feels aggressive. So there might be some trick you could do where maybe you start with like a reasonable timeout, right? And then rip through the list in order with like a kind of short timeout, assuming that they're going to be close. But even that seems kind of fucked. Maybe you only start asking the other guys after some. Yeah, it feels wrong. There's no answer in here that feels like sane to me, but maybe I just have to think about it a little more. But anyways, this is freaking cool. Guys, for once in our fucking lives, we were like, how hard could it be? And it wasn't that hard. For once in our goddamn fucking lives, we actually did it all once. Usually we say this and then it's 3 streams. I just discovered that Zig has std debug dump hacks. Wow, I wish I knew that because that's very useful. So thank you for that piece of information. Anyways, so mission accomplished. I think we call it there for today. I really gotta go play the new Arc Raiders patch. So, we've got our priorities in order here. So I'm gonna do that. Thanks for watching, guys. If you liked what you saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. That order, that area. It's 2:45 now. So if you're watching live, anywhere from like 2 and a bit hours ago to 2 hours from now is like when you might see us. Yeah. We're working on a SIP client so I can answer my doorbell using internet phones. No dependencies, basically. Swing back by, I don't know, check out the YouTube, check out the Patreon, check if you have a Twitch Prime, YouTube members, get some stuff as well, go take a little peek skis. Thanks for watching. YouTube, peace out. Twitch, let's find someone to raid.